topic is the flow chart. Okay, it's here the algorithms, flowchart, and pseudocode. So while implementation, you just don't go directly and write the code, right? So in our previous SDLC topic, we actually saw the step three was actually implementation, right? So you don't just do I see the problem and I will sit down and I will write the code and that code will execute flawlessly. That doesn't happen like that. You you think about the problem, how the problem will actually turn into a proper sequential stepwise solution. You first define the algorithm. So in simple terms, I can say it like algorithms are like a recipe which can make your biryani a very excellent, luxurious taste, and it can make a khichdi out of it. So, algorithms is basically a recipe. It tells you an exact steps how the problem should be solved, a sequential manner how the problem should be solved. Whereas the flowcharts are the visual representations of those algorithms for a proper understanding how the workflow will look like, how the workflow will look like actually. For instance, algorithms just show you a complete procedure. I will give you a very short example for this event. Suppose you are building an authentication system for any kind of web application or any kind of platform. So, what algorithm would say? There is a button on which a user clicks. It will open a sign up form, a Google sign up form, and their user will select their Google account, and done. The authentication is completed. This is what the algorithm will say. The flowchart will say first the process starts. There will be visual representations. I will show you in the further code even. So the process starts. User clicks. If the user clicks on a specific account, then the authentication will happen. If there is no authenticated account, it will fall back. So it flowcharts basically contain the loops, the fallback loops, where algorithm doesn't specify it completely. So flowcharts give you the real workflow idea of how the algorithms will work in a visual manner. Algorithms are a recipe for your complete procedure to be problem to be solved in a very sequential manner. Pseudocode is the implementation of your flowchart. Like flowchart, you had a complete visual representation, right? The pseudocode is actually a general written in language. It can be in any language or it can be without syntax, full of errors code even. It's not an actual code. It's just a pseudocode to give a informal way of the we understanding how the workflow will actually look like in the code. So I will just walk you through some example symbols of the flowchart. These are actually really important for the exam perspective even. So here the oval, this first symbol, it represents whether an algorithm has started or ended. So whenever your flowchart starts, it will start with this symbol, an oval, and here will start whatever the process is. You will write here start, and then comes the rhombus kind of symbol, which is used for input and output. If specific inputs needs to be taken from the user or the output needs to be shown, that's all it's been represented via this rhombus symbol. If there is a processing happening, it will be showcased with this rectangular symbol. So for the example I was just mentioning a few minutes back, there was an authentication system, right? So for example, if a user clicks their user account, there is a few delay, right? It happens a loading process, like the complete user details are extracted from the Google account of that user. So all that processing can be represented by this rectangular box. And if there is a decision to be made by the code, it is shown by this rhombus over here. So if there is a authenticated user, it will fall back to as an authenticated. If the user is not authenticated, it will show login and sign in button. So that's what a very brief idea about flowcharts would be. So I will next thing coming up is compiler versus interpreter. So this is actually really important for the exam. This can directly come up in your 2 markers or 2 markers here, the compiler and interpreter, and it's actually very fundamental to know even. So what compiler and what interpreter is actually. So compile what compiler actually does is it takes the entire code, it scans for the entire code and translates into the machine code. So you might have done in your PPS labs even. You have written the code and then you do CC, then your file name, then you get a file named a.out, right? Then you execute that a.out. So that a.out is actually a machine code which is compiled by the compiler. C compiler, Linux-based compiler is used over there. CC. If you're in Windows, you might have used GCC compilers for compiling the C level C language C code to the machine code. So for different operating, there are different set of compilers available. So coming back, compiler actually takes the entire program and converts into the machine code. That's what a compiler does. Whereas interpreter, it translates program line by line. So instead of just taking the entire code, it will first read the line one and then go to the line two, and then first line one is converted to the machine code, then it comes back, line two is converted to the machine code, and that's how the complete process will follow along. So interpreter converts line by line, compiler does it all at once. So compiler time is actually very fast because it takes the entire program and converts all at once. Interpreter, on the other hand, is slow. It does line by line. So suppose your program has 1,000 lines, it will take a very good amount of time to convert all that using interpreter. And also the compiler requires more memory, the interpreter requires less memory because each line is converted and then executed, and then it's flushed from the memory, then it's converted, and then it's been running. So it's not the complete program being doing that, so it requires less memory, whereas a compiler requires more memory. Few examples are here for like the C language, the Java language. You might be learning this in your third semester, the upcoming semester, Java. C is there, Java is there, C++. All of these are under the examples of compiler. Whereas an interpreter, Python, and JavaScript are the examples are even there, uh, like the Ruby, Rust. So I guess you all might have got a very good idea what a compiler and interpreter does. Coming to the next thing, number systems and architecture. I guess everyone is going good, right? How is the session going? Thanks. So we are halfway done, I guess. Let's explore more. PPS is actually a very scoring subject, so make sure you get a very good grade in your PPS subject. It's actually a very interesting subject even. So talking about the number systems and architecture. So there are basically four types of number systems: binary, octal, decimal, and hexadecimal number systems. Binary, as the name says, it has two elements, the 0 and 1, which the machine level language understands, the zeros and ones. The octal number systems consist of 0 to 7, decimal 0 to 9, and the hexadecimal 0 to 9, and then A to F. Consisting of complete 16 elements. Decimal has then 10 elements, octal has 10, octal has 8, and binary has 2. A simple conversion here, it's shown like there is a number given in binary 1011, which is in base 2, that is its binary. You can simply convert it like this. First, the number 1 is taken as a coefficient 1, and then 2 as the base is 2. All of the coefficients are multiplied with that. So it comes with 2, and the power is 0. Indexing from here 0, 1, 2, and 3. So the first element has the index 0, so the power of the 2 becomes 2 power 0, and since the first letter is 1, the coefficient becomes 1, and hence this is 1 into 2 power 0. And so adding to the next thing, 1 into 2 power 1, index is 1, 2 power 1. Adding to another one, the coefficient is 0, power is 2, 2 power 2. The coefficient is 1, index is 3, 1 into 2 power 3. You sum the complete thing, you will be getting 11. That's how a simple binary conversion would look like. If you want to convert a decimal number to binary, it will follow something like you take the number, you divide it by 2, you note down the remainder on the right hand side, and you keep on dividing it 2. And once your complete remainder comes to 0, From the down, like from the bottom, you keep noting down the zeros and ones from the left hand side on your sheet. That's what a decimal number when converted to a binary would actually be. Uh, was I audible? Okay. So as I gave you a very brief idea, even how the C language evolved and what kind of different set of game changers it is bringing in our industries, in the market right over now, even. Um, Dennis Ritchie, in 1972, actually developed this language, C, and it was actually used to implement and build the Unix systems. The Unix systems were actually used to build that, like the operating systems designing were actually mentioned. So back then, operating systems were evolving. The Linux kernel was coming up. So this C language played a very crucial role in the development of those operating systems. Okay, so this is a middle level language. Gets converted to machine code by the compiler, as we have seen earlier even. So the structure is very simple. Hash include int main and return zero. I will show you live examples even with the code coming up. Let's show it right over now. You might have gone in your PPS labs. So in your PPS labs, you might have connected to a telnet server. Here I am showing you with my WSL directory installed on my Windows system. This is a Ubuntu, actually, WSL running on Ubuntu on a Windows system. Here I will be showing you some basic code examples of a C language. Okay, I've got into my Linux terminal. Let's clear this up. And first of all, just get me to the directory. Test. Yeah. Okay. So I've already one file made, I guess, here, test.c. Remove this. Okay, we are good to move forward. So there's nothing up here. You might have used some basic commands on Linux, like the command ls, actually used for listing all the files available in this directory. As there is no files available, it shows an empty one. If I create some files, you can create files even using touch a dot txt, for example. It will create a file. You can also create files using vi command, vi editor, like a ab.txt. It will open an editor for you. Escape shift colon wq will write and exit. You list down again, you can see that ab.txt is again there. So there are different set of editors you can use. There is a nano, even there is a cat uh, editor even, where through which you can edit. So primarily we will be using the vi editor for this. Let me clear this up. And okay, so we have this a.txt. Remove this. Okay, so let's create a new C file, test.c, and first right over. You press I in the VI editor, Vim editor. You press I to write something in Opus, to write the textuals here in this file to come up in the insert mode. So you first write a hash include stdio.h. This includes all the. This is actually a library, basic header file, which includes all the standard uh, printf functions and variables creation in defined in over here. So the next thing is int main. This is the main function defined like this. like the parenthesis, and then there is a curly braces defining this is the scope of this function starting from here to here. So you first write up here like printf hello world. In every programming language, you might have written the first sentence as hello world. So we are even writing up here printf hello world. So close this and right. So every statement in C language has this header file stdio.h and then a main function and then some code written up over here. Okay, and every expression ends with a semicolon. So there needs to be a definitive semicolon over there. So you written zero, which specifies zero is for exit. So in C language there is a no true and false conditions. Everything is zero or one. Zero means false, one is true. So zero means exit over here. We have actually written int over here, right? So int here mentions what type of what this main function will return. That is why we are returning zero over here. If you just write main, it will still execute. We don't write return zero even. So some compilers complain about that. Like it needs to be a mentioning the program has exited. So return zero is duly mentioned. Duly needs to be mentioned. So good practice mentioning it here. So we have mentioned it. So we write and quit this program, and we can see there is a test.c available. We compile this with cc test.c. Yes, the program is now compiled. You can see a.out is over there. And now we run this machine level code, which is compiled. The test.c is converted a.out to the machine level code. So now you can see the hello world is over there, right over there. Okay, so let's do some more examples with this. So let's create few variables even. For example, I will come back to the insert mode and I will write int marks equals to, let's say we got a perfect 70 score in our PPS subject, and we write over here, yeah, scored a perfect percentile D, small d, represents this integer, like whatever we are mentioning over here. So printf. This statement is actually used for printing a formatted string. Formatted string. I'm repeating it again. It's a formatted string. What this actually means is this is a complete string, right? A scored a perfect. Then comes a percentile D. So what this percentile D signifies is whatever is written after it in a sequence, marks. Marks is a type of int, right? Marks is a type of int which comes up over here, and this string gets formatted and gets printed as a scored a perfect 70. That's how printed formatted strings will work. So if you are writing some characters, you mention it with C. If you're writing with some strings, if you mention it with S. So there goes by. If you are mentioning some kind of float, you mention it with float, and thereby goes a complete list, which we will see in further upcoming modules. So I mentioned it percentile D, marks, and return zero. So let's go exit this program and then compile this cc test.c. Compiled successfully, and then we will run this dot slash a dot out. You can see the output. A scored a perfect 70. So that's all. That was all. Very basic structure mentioning of that C level language, how the code actually gets executed and gets compiled even. Let's move further. Okay, so in every language, either it might be C, Java, Rust, Ruby, anything, any kind of language has its own keywords, the variables, identifiers. So what are keywords? Keywords are basically the reserved words which the compiler uses for itself. For example, in our coming back to the VI, our code, int. You can see this. Int is a data type which is reserved in this complete C language. We cannot use variables with named as int as these data types. I cannot replace marks with int. That will be an error because those signify something else. Those signify some other values or keywords reserved with the language of C. There are 32 reserved words like int, if, return, while in C language, and identifiers are actually the variables and functions. No, there are specific rules for it even. So here, this is an identifier. This marks is an identifier. Marks is an identifier. Marks this identifier cannot start with numeric values. Like I cannot do something like this. This is not a valid identifier. I cannot do something like this. This is not a valid identifier. I cannot put the spaces in between. I cannot put the dashes in between. This is also not a valid identifier. So identifiers follow a specific rule. They don't start with a numerics. They don't have spaces in between them. They don't use dashes or special characters. Like even I cannot use this kind of things even in the um, identifiers because those represent something. Those represent some other sort of symbols in the language of C. So it will give you a lot of compile errors if you try to do that again. So identifiers are the variables and name of the variables and functions, which is used to identify a specific value or what the function will a procedure. Functions can be termed as a procedure or an algorithm set of code blocks. So that's what an identifier and keywords are actually. So as I told you, format specifiers. Percentile D represents an integer, what we mentioned up over here even. The percentile D used for an integer format specifier. Marks are inserted in the string as a format specifier of a percentile D. Float, percentile F, character for percentile C. So that's what this will actually look like. Variables are simple. Memory locations used to store data must be declared before use. You have dal, it might be getting stored in some kind of container, right? You're having a biryani, it's in a container in your fridge. So variables are like those devices which are storing the actual value in it. So coming to the next point is actually the input and output statements. Printf. Printf, as I just used up over here even, it's a simple command which displays on your screen whenever executed. It's an output. Printf is used for output functions, output statement. Standard output function used to display data on the screen. Whatever data is been whatever the string or whatever the data is being inserted with the printf function, the data gets displayed on the screen. That is an output statement. Scanf, on the other hand, takes the input from the user from the terminal. I will show you the scanf implementation even. So scanf takes the input from the user and uses in your code wherever it has required. I will show you a simple example of a scanf even. So suppose you want to take in marks. So let's take the marks from the user. Scanf, and here you mention what type of format specifier the marks is. Percentile D, comma, amp percentile of marks. So this amp marks, like the hand symbol you can see, it's actually read as amp marks, specifies this percentile D, that is the integer which is taken from the terminal, which the user is inserting, should go to this value. So amp represents the address of marks. This value goes to this address. That's what the scanf takes the value and puts into wherever the address needs to be mentioned. Like it goes to the marks over here. So you took the marks from the user and you're getting uh, printed image. So let's write some. Yes, you can use the scanf wherever you require, but the thing is, it should be mentioned in a proper sequence. For example, if I just comment out over here and write scanf percentile D ampersand marks, any guesses what this would fetch? See, what actually will happen is int marks will be defined in your compiler when this computer code runs. Marks is defined in your code, and the next statement is printf. Yay, scored a perfect. and then a random value will come up over here. A very random garbage value will come up over here because you didn't specify what the marks are. Like there is a no value for marks, right? So what C language does is it stores a garbage value for the value as marks, and that gets displayed. Then you take the input from the user. So in this case, it doesn't make any sense. You're printing the marks before even taking from the user. It doesn't make any sense, right? So scanf can be used anywhere, but the thing is that should make sense with your code implementation even. So I will show you this one even. Like let's comment this out and print this. You will see a gibberish value for the marks. See, 326767. When I run this again, let's compile this again. You see a very gibberish value getting stored. And I will tell you a very short and interesting reason even for this. When I have when I have compiled this right, and then run this program, I see a garbage value 32767. I have run it again. I see a 326766. I've compiled it again. I don't see it. Let's see. 32766. So the reason is whenever I have compiled it, a dot out, it will store a garbage value. If I compile it again, it will store it to some different storage value. Like the garbage value gets changed whenever I compile. A short note, if you're interested, you can have it. So that's how a scanf and a printf functions actually work. So scanf takes the input from the user, printf prints the data and output on the screen. And the next thing coming up here is operator precedence. So you might have done the Bodmer's rules and all in your lower grades or in mathematics. So operator precedence actually follows this associativity and categorized in this order. So it is a postfix like the parentheses, square brackets, or the arrow functions or dot or plus plus. So plus plus is actually used for incrementation. I will just show you over here even. Vi test.c. If I do plus, one second, I'm on insert mode. Yeah, okay. So I'm on insert mode, and if I do this plus plus, so when I compile this, cc test.c, vi test.c, oh, it's just right. Just give me a second. Okay, so coming back to the thing, I was mentioning marks. Okay, so let's mention marks as 60, and then let's save this and see. Compile this dot slash a dot out. I can see the marks is getting added over here, right? So this is an increment operator. Plus plus is a unary increment operator. Operators you will see in a day two event. Just for a glimpse, I have shown you up over here. Operator 61 plus plus. So I will do one more thing. Vi plus plus. I've written plus plus marks, right? Now I'm going to do something like this. Marks plus plus. Any guesses what would happen? So run this. You can see the number is 60 there itself. It hasn't incremented. So difference matters, right? So that's how the operator precedence is. You're adding it before, you're adding it afterward. This is pre-increment, this is post-increment. Adding afterwards is post-increment, adding before is pre-increment. So after the statements gets executed, then the marks is getting added. That's what this is. And the unary operator, basically plus plus and minus minus. Unary operators could be size of, mentions the what is the size of a particular variable. If you just do something like this over here, insert mode, printf, the size of marks variable is percentile. See, okay. So if I do something like this, size of marks. Okay, so I do CC test. 1 second. I just S V I W escape shift for them. Okay, so this actually mentions the size of being used. What is the size of the characters, multiplicative inverse. So operator precedence basically tells you how your expressions should be evaluated. So if there is an expression, for how that expression will get executed. For example, I will just show you. Let's clear this up and let's create a new file. Vi test vi operator.c. Okay, let's write some basic code over here. Set mode include stdio.h int main, and suppose this is our expression. Printf percentile d, our expression evaluated as percentile d, and our expression could be something like this: 4 star 4 plus 3 slash 2 star 2 3, something like this. So how will this expression will get evaluated? So first, what happens is the multiplicative has the associativity of left to right. So the first 3 by 2 gets evaluated, and then comes whatever the 3 by 2 is evaluated as. It's evaluated as 1, and 1 times 3 it gets evaluated as 3, and then comes 4 plus 3, that comes as 7. Let's see. Not CC, CC operator. What was that file name? Yeah, dot slash data out. You see our expression is evaluated as 7. So that's what that's what this operator precedence is actually. It shows you how the associativity, how the expressions will be evaluated: multiplicative, additive, and assignmentative. I will be adding some homework questions for you for operator precedence. This might come up in exams. So after the session, you might be getting those operator precedence things. This might come up in your 2 markers even. So coming to the next topic is type conversion and typecasting. So simple exam, nothing major. We are moving forward to the completion of the session. Most of the topics are completed, I guess. So type conversion and typecasting. So type conversion, there are actually two types of conversions: the implicit and explicit typecasting. So implicit type conversion happens when you by the compiler itself. You don't actually do it; it happens automatically. So for this case here, float x equals to 5. You have mentioned an integer x equals to 5, but when you print this x, it actually becomes 5.0, not 5. So this is done by the compiler. We don't do anything. That's how the compiler actually does on its own. On the other hand, there might be something like this: int x, and then you're mentioning type of int 5.75, and x becomes 5. This is another type of type casting. So I will show you with code examples even. So let's do in this file itself. Insert mode. Int data equals to 41, and we type in here. Let's mention a float FLO80. Okay, so the float, and then comes here percentile f, and then data. Let's try to execute this. WQ, and then CC operator C, error out. So you can see this. It's coming up 14.000 automatically. We didn't mention anything after decimals, right? I will mention you one more thing over here. Suppose we are mentioning the value of pi. Insert. Mentioning the value of pi. 3.1415926531, something like that. Okay. The next thing is we're actually mentioning data. Uh, Simple operation, nothing major. Okay. The data is not defined because we have changed the variable name, right? So we have to mention up pi over here, pi even here. Escape shift forward, WQ, execute this, you run this a dot out, and it will show you 3.1415 and something like that. So I will show you one more thing over here. With percentile f, you can mention something like this. Checkpoint point 2. So what this specifies is after decimals, I just wanted two decimal places like 1, 4, and 5. Let's say the example, CC operator, and then in and out. So you can see just point 2 means I'm getting only two decimal places. If I just update it to like 4 or something, four decimal places will be picked. So four decimal places. CC operator C, then in and out. 3.1415 So specifically, whatever we are mentioning over here, there, point 2 or point 4, those decimal places are only coming up. Those number of decimal places are only coming up over there. So a very generalized idea, type conversion are of basically two types. One happens at the compile time, one happens at the runtime. Compile time, for this example, float x equals to 5, x becomes 5.0. Int x, you're actually doing it manually, right? You're mentioning int 5.75. This is a manual conversion, so this is done by the programmer itself. So there are two types of conversions: implicit and explicit casting. So that's all for this session. Uh, any questions you can mention up over here? Okay, any questions to be cleared you can mention up over here. Yeah, sure. We will be sharing this complete document once the session ends in the groups itself.
If you guys have any questions, you can unmute yourself and ask.
If you guys have any doubts, you can unmute yourself and ask. Okay, so assembly level languages, I will just walk you again. Assembly level languages are basically the upgraded version of machine level languages. So machine level languages had zeros and ones, right? So for specific use cases, mnemonics came up to mention specific operations like addition. There was an add mnemonic was used for moving the value that is. Uh, I will just show you some. You can see the chat even. Move AX3. So what this actually does is it moves the value 3 through this variable AX. If you do something like this here, this is the machine level assembly level code, you can say. Right. And then if you do something like this even AX, after doing that, AX add colon 4. So value becomes 3 plus 4 7. So this AX becomes the variable, add becomes the mnemonic, what we call the addition. Behind the scenes, binary addition actually happens from the decimal conversion to binary conversion, and add takes in place with that. So assembly language introduces mnemonics for the binary level machine code. And typecasting, it's simple. Whatever manual conversions you're doing, that's what typecasting is. I just shown you an example over here even. So this is int x and int 5.75. You're typecasting this. 5.75 becomes 5. This is a manual conversion. This is what casting is. They're manually doing it. On the other hand, conversion happens automatically by the compile time. By the compiler itself does it. Float x equals to 5, x becomes 5.0. This is conversion automatically done by the compiler. Okay. Any more doubts? Yeah. Casting is done manually. Conversion is done uh, automatically by the compiler itself. So that's what the power of C is there, right? So I will give you a very generalized example for this event. C language and any other language which doesn't give you this much power. Uh, Python, I guess you might have heard even there is a Python language and there is a C language. So Python doesn't give you this low level kind of power, whereas C gives you. For a very generalized example, like analogy, I can just give it like imagine Python as your G wagon or your Land Cruiser, something very crazy luxurious cars. It has every kind of sports mode, off-roading features, and all. Right. Talking about C language, it goes to very legacy level old vehicles. Manual transmission. There is no automatic transmission. You can control your engine. You can control your superchargers in your engines. So C gives you a very that level power at the core level. It imagines the programmers are actually very genius with it. So if something goes wrong, if the programmer does it wrong, it can delete its own brain even with the C language. So C is powerful when used correctly, obviously. Okay, any more doubts? Abid, is this session being recorded? Okay, so this session has been recorded. Yeah, session is completed. If you have any doubts, you can pull it over here.
So yeah, guys, that was the session. Hope you liked it. So we will be starting with the day two tomorrow. We will be covering like if else statement and for loop, which is very crucial for your subject. So make sure to join it.